Hello differential equation students. In this video we'll take a look at an example of how to solve non-homogeneous higher order linear differential equations with constant coefficients. I think we did a process, the previous step, the previous video. Now let's take a look at another example that are not necessarily simple. So we're going to basically solve this particular problem right here. And let's see how do we do that. Let me recollect the process. If you recollect the process, ladies and gentlemen, the process that we had earlier was the very first step one is to rewrite the differential equation in this form, and in the left hand side happens to be the operator form, and then we have the right hand side, and then we find the annihilator, we call it as the h of d, and then we find the yc. As you know, the general solution is, y is equal to yc plus yp. yc is the solution that comes off of the homogeneous problem, and yp is the particular solution that comes off of the non-homogeneous part. So to do that, first we set the n is equal to 0, and then we solve for, then we get the f as h, and then we get the yc, and then we operate f of d and g of d together, and then that's going to give you the f as nh. And then we know that yp is in the f as h minus f as nh minus f as h. And basically the yp is a linear combination of the elements that are in f as nh minus f as h. But the thing is that because of the linear combination, we are going to have constants alpha and alpha 2. And then we're going to solve for those constants. And then once you do that, then you can figure out your yp. And you already have yc, and now you have yc and yp together. And then you add these two, you get the solution y, and that's how we solve this one. So let me execute this process with this particular example. So the step one, as we said earlier, let's see, the step one is to figure out the rewrite this in the operator form, which is going to be, ladies and gentlemen, d squared minus 3d plus 2 of y is equal to x squared e to the x, right? And here is your f of d, as you see here, that's your f of d. And the annihilator for this one is, as you see there, is going to be d minus 1 because of the e to the x, right? E to the 1x. And because of the x squared, it's going to be cubed. So your g of d for this would be d minus 1 cubed. That's our step number 1. We did that. Let's take a look at the step number 2, finding basically solution to the homogeneous problem. Let's quickly do that. Let me change the color. So if we do that, ladies and gentlemen, and that would be basically solving this one, d squared minus 3d plus 2 of y is equal to 0. And if I try to find the characteristic equation, and characteristic equation is going to be m squared minus 3m plus 2 equal to 0, and that tells me that my m is equal to, that tells me that my m is going to be equal to 1 and 2. 1 and 2. Therefore, the fundamental set of solution for the homogeneous problem is going to be e to the x and e to the 2x. And so therefore the yc, the homogeneous part, the solution of the yc or yh, whatever you want to call it, is going to be equal to a linear combination of those two functions, which will be c1 e to the x plus c2 e to the 2x. So we pretty much done with this particular section right there. Now let's take a look at this one, the step 3. Let's change the color. So we are trying to find the yp, the first part of the yp. To do that, I'm going to operate f of d with the g of d, right? And then I'm going to set it equal to, I'm going to operate this on the function y. And basically, I'm trying to find the annihilator. I'm trying to find the function that gets annihilated by this f of d operated on g of d. When I do that, ladies and gentlemen, as you see here, then I'm going to have a d squared minus 3d plus 2. So I have this operator operated on d minus 1 cubed, and the whole thing is operated on y is equal to 0, whose characteristic equation, by the way, is going to be m squared minus 3m plus 2 multiplied by m minus 1 cubed equal to 0. And if you simplify that, you're going to have your m to be 1 1 1 and one more 1 and 2, so you have 4 1s and 1 2. So that's going to give you that f as nh. F as nh, that would be e to the x e to the x squared e to the x, and x cubed e to the x, and e to the 2x. So we are right here. We finished this step. Now let's take a look at the yp. To do that, I'm going to subtract f as h from f as nh. When I do that, let me write it down. So if I do the f as nh minus f as h, that's going to give me, let me copy this to make my life easy. And minus f as h, let me copy this also here. If I do that, you would agree with me that e to the x and e to the x will go away, e to the 2x and e to the 2x will go away. So I will be left with the following: the set x e to the x squared e to the x cubed e to the x, and so therefore yp is going to be a linear combination of all these three, which is, sorry, not yp is going to be a linear combination of all these three, which I'm going to call, if you don't mind, as capital A is a constant times x e to the x plus another constant b times x squared e to the x plus another constant c times x cubed e to the x. There is nothing wrong in using alpha, beta, gamma, but we might as well use this one as well. Alright, so now that we have yp, we know that the yp is a solution to the non-homogeneous problem, right? So yp is a solution to this one. So therefore, when I plug in yp into this differential equation, that I should get this. So what do I mean by that? By which I mean, if I have, let me use a different color, by which I mean, if I have yp double prime minus 3 yp prime plus 2 yp, right? And that should give me x squared e to the x, right? That's what that yp means, to be a solution to a non-homogeneous problem, right? It's a particular solution. It must be a solution. It must be a solution to the therefore it's a solution to the non-homogeneous problem, and so therefore when we plug into the differential equation, we should get the non-homogeneous part on our right hand side. So to do that, I should know my yp prime and yp double prime and yp prime and yp. So let's compute that real quick. So what is the yp prime? So if I do the yp prime, I would have a, and then the derivative of this using a product rule, 1 times e to the x, right, plus x e to the x. If I find the derivative of the second one, b is a constant, it says as is. The derivative of using a product rule, the derivative of x squared is 2x times the second one is as is, plus if we keep the first one as is times the derivative of e to the x, which is e to the x. And if we do the derivative of the third term, that is c times the derivative of x cubed is 3x squared, we keep the second one as is using the product rule, and x cubed times e to the x. And similarly, if I do the yp double prime, then I am going to have the following, which is a times 2 plus x e to the x plus b times 2 plus 4x plus x squared. I'll let you simplify that on your own, right? And then plus c times 6x plus 6x squared plus 6x plus x cubed e to the x. I'm missing an e to the x over here and e to the, well, yes. All right, so I'm missing, right. We are good there. So that's what we have now. So what does that mean? So if I plug this in, right, if I plug this in and if I take all these, right, into this differential equation, I should have x squared e to the x right there. So let's take a look at how do we plug it in and do that. Now we're going to combine all these three, right? We're going to combine, yp prime, yp double prime, and we're going to plug this back in here, right? We're going to plug this back in here and then set it equal to ex squared e to the 3x. That's going to help us solve all these a, b's and c's, right? So let's see, how do we do that? I'll let you do the simplification on your own. So if I simplify this, what we are going to have is the following. Let me change the color. So if you take a look at the yp double prime and minus 3 times yp prime and then plus 2 times the yp, right? So it's basically, you take a look at this, subtract 3 times of this, right? You're going to multiply 3 times with this, right? You're going to multiply 3 times with that and then subtract and then multiply 2 times of this, which means you're going to multiply 2 times of this and then add that. When you do that, what you're going to have is the following. You're going to have 0 times x cubed e to the x plus, let me change different colors in here, b plus 6c minus 3 times b plus 3c plus 2 times b of x squared e to x. Let me just show you how this one comes so that you can kind of see. So I'm looking at the x cubed, right? The very first one, I'm looking at the x cubes, all the x cubes. So if you take a look at all the x cubes, yp double prime has only one x cubed e to the x term, right? Only one x cubed e to the x term. That one is simply c. So you have one of those. If you take a look at the yp prime, that has again only one of them. That is x cubed e to the x times c, right? So if you just these two, and then if you take a look at the yp, that has only this, right? So what do? We take a look at the 1 times of this, that is c times x cubed, minus 3 times, minus 3c x cubed, and then plus 2 times. So this 1 times, that 2 times adds up to 3, and then you subtract 3, that's going to give you a 0, right? Similarly, if you take a look at the x squared term, that doesn't become 0, that becomes a little tricky in here. So if you take a look at the x squared terms, let me show you what do I have. What I'm going to have is, here I have in the yp prime, right? In the yp double prime, the x squared I have, you see I have a b and I have an x squared term. 1 times b, x squared right there. And then I also have, 6c right there, right? X squared e to the x, so I have a 6c. So that's all I have, right? That comes from this one. Minus 3 times, because it's a minus 3 times the yp prime. What kind of x squared do I have? I have one x squared here, I have another x squared there. So this is, 3b, right? Minus, 3b plus 3c, that's a 3c right there. And then if you take a look at the yp, I have 1x squared term, so this plus 2 times the b, right? That's how I got it. So similarly, if you do all that, you're going to have the following. Let me change the color. You're going to have for the x e to the x, for the x e to the x, you're going to have a plus 4b plus 6c minus 3 times a plus 2b plus 2 times a. Right, that's what you're going to have for the x e to the x. And the next one is just the e to the x, right? Just e to the x. For the e to the x, you're going to have the following, which would be let me just move this up here so it's easier. For that, you're going to have 2a plus 2b minus 3a coming off of the yp prime plus 2 times there is no e to the x, so it's times 0, right, coming off of the yp of that times e to the x. And so that's all you have, right? And we know we know that that must be equal to x squared e to the x. So now what we are going to do, we are going to set this equal to let me use different color. We are going to set this equal to all of these, right? All of these, we're going to set this equal to x squared e to the x. What does that mean? That means this one is going to be 1 because that's x squared e to the x. There is no x e to the x term on this side, so that's going to be 0, right? That's going to be 0. And there is no e to the x term on here, so that's also going to be 0. So therefore this is going to be, this is going to be equal to 1, and this is going to be equal to 0, and this is going to be equal to 0. Now if I simplify that, ladies and gentlemen, what you're going to have is, again, if you can simplify this, if you simplify this furthermore, you're going to have the following, and that would be, I'm just simplifying all these, right? I'm just simplifying all that, this whole thing I'm just simplifying in terms of x squared, x, and so on. If you simplify all that, what you're going to have is the following. You're going to have, so if I clean this up, right? If I clean this up, right, so I have like a b here, I have a minus 3b and a minus 2b, so it's going to be gone. You have a plus 6c, and then you have a 9c here, minus 9c here, so you're going to have minus 3c. So if you clean it up, what I'm going to have is, I'm going to have 0 times x cubed e to the x. That's a 0, so I don't have to worry about them. Plus, let me change the same color. So plus, then if I simplify the second part, I am going to have negative 3c x squared e to the x, right? Times no, what am I doing here? That's no, yes, that's right. Plus, right, plus the next one is going to be minus 2b plus 6c x e to the x. Let me rewrite this in a nicer way. So this is going to be minus 3c x squared e to the x. And then I have, what else do I have? I have minus a plus minus a plus 2b times simply e to the x. And all this is equal to, all this is supposed to be equal to e to the x. So that's gone anyway, I don't have to worry about it. So this is going to be equal to 1, and this is going to be 0, and this is also going to be 0. So when I do that, ladies and gentlemen, I'm going to get the following. And that is minus 3c is equal to 1. That tells me that c is equal to negative 1/3. And minus 2b plus 6c is equal to 0. And that tells me that, minus 2b plus 6 times negative 1/3 is equal to 0. Therefore, minus 2b is equal to 2. And that tells you your b is equal to negative 1. The third equation is, minus a plus 2b equal to 0 minus a, b is equal to negative 1. So it's going to be 2 times negative 1 equal to 0. That tells you minus a is equal to positive 2. So therefore, a is equal to negative 2. So that's how we find our a, b, and c. Now if I plug it back into my yp, now if I plug all these back into my yp, ladies and gentlemen, what I am going to have is I am going to have my yp to be, therefore my yp is going to be a, which is so basically I'm looking at this, right? Basically I am looking at this, right? So therefore my yp is going to be a, which is negative 2 x e to the x, b, which is negative 1 times x squared e to the x, c, which is negative 1/3 x cubed e to the x. So I got my yp. And so therefore the next step, the last step, is finding the general solution. And that's our step number 6. So the general solution is, y is equal to yc plus yp. And here my yc is, as you see here, yc is c1 e to the x plus c2 e to the 2x. So if I write that same color right there, so it's going to be c1 e to the x plus c2 e to the 2x. And the yp is, I'm just going to copy paste it right here. And if I rewrite it, it's going to be that right there. And that's a solution right there. And if you want to simplify, you can simplify this further and to something like this, but it's not a big deal. You can say this is c1 e to the x plus c2 e to the 2x minus x e to the x times 2 plus x plus 1/3 x squared. If you want, you can also combine e to the x right here. That's not a big deal, but you can just leave it like that. That should suffice for this problem. And that's how we solve these kind of problems. It's a longer problem, but that's how we solve all this. So here's the solution to that differential equation yp double prime, that y double prime minus 3y prime plus 2y is equal to x squared e to the x. All right, ladies and gentlemen, I will stop it right here. We will continue. With in the next section. We'll continue how to solve higher order linear differential equations with non-constant coefficients. We're going to deal with non-constant coefficients using this method of reduction of order in the next video. I will stop it right here.